In today's lesson, we're going to learn about four different types of angle relationships. The first one we're going to talk about is complementary angles here. Complementary angles are going to be two angles with a sum of 90 degrees. So they sum up to 90 degrees. They can be adjacent or non-adjacent. What adjacent means is that it's next to. Non-adjacent would be that it's not next to. So just a side note here for you, means next to. To help you remember it adds up to 90, I kind of use the word itself complementary. I turn the C into a 9. The 0 is going to be, the O is going to be my 0, and that makes a 90 here. So that helps me remember that complementary means adding up to 90. So the first problem, example 1, I want to solve for x. I have this right angle, this box, which means 90. I want to subtract the angle I know from 90, which is the 15. That gives me 75 degrees left. So my answer is x equals 75 degrees. To check, I can add up those two angles together, 75 plus 15. That will get me back to my 90. In example number 2, we have angle LMN and angle PQR are complementary. So right away, I can highlight that word because I know I'm going to use it. Remember, complementary means they sum up to 90. Let's see what more information I have. Find the measures of the angles if angle LMN equals 4x minus 2 and angle PQR equals 9x plus 1. Those are my two angles. That's the information I was given. So I'm going to add up those two angles together to make 90. So 4x minus 2 plus 9x plus 1 equals 90. And just to show you, these would be two complementary angles that are not together. So we have LMN and we have PQR. They would add up to 90, but they would not be adjacent. They do not have kind of the same letters, that shared ray in between them. So we go ahead and solve this equation. We always want to combine the terms on each side. So we have 13x. Negative 2 plus 1 is going to give me negative 1, and I still have it equal to 90. Now that all my variables are combined and all my numbers are combined on one side, I got to move it over to the other side. Combine those plus 1 with the 90. That's going to give me 13x equals 91. Divide by 13. X is going to come out to be 7. Now, that does not answer my question. My final question is find the measures of those angles. So what I need to do now is plug this 7 back in. So I go to angle LMN and plug in 7 when I have x. So 4 parentheses 7 minus 2. I'm plugging in that 7. That gives me 26. 26 degrees for angle LMN. Now for angle PQR, again, plug in where you see x, 7. 9 times 7 plus 1 is going to be 64 degrees. That is how we work with complementary angles. The next type of angles we're going to talk about today are supplementary angles. So these angles are going to be two angles with a sum of 180 degrees. So they add up, they sum up to 180 degrees. They can be adjacent or non-adjacent. So they can be adjacent or non-adjacent. Remember, adjacent just means next to. To help me remember for this one that they sum up to 180, I turn the S into an 8. I turn this U into a 0, and I put a 1 out in front because that makes my 180. That can help me remember that supplementary means 180 summing up to. Example number 1, we want to solve for x. So we have the information we are given. Let's highlight that angle A and angle B are supplementary. That is given to us. We know they add up to 180. Well, we go ahead and set up a little equation. We have x, that's the unknown angle A, plus angle B, which is 120, are going to equal 180 together. Super easy, just subtract 120 from 180, and you will get x equals 60 in this case. So measure of angle A will be 60 degrees there, but x equals 60. For example 2, we have if the measure of an angle is 76 degrees, find the measure of its supplement. So again, one word that kind of comes out in this problem is supplement. Means they're going to add up to 180 together. So all I do is I take 180 and I subtract the angle I know. So I know these two add up to 180 together. I only know the 76 degrees of it. How much is left for that other angle? So I go ahead and subtract, and my answer comes out to be 104 degrees. So the third angle relationship we're going to talk about today is linear pair of angles. So a linear pair is when two adjacent angles, which means next to, so two angles next to each other, whose non-common sides form opposite rays. Linear pairs are going to be supplementary. And we just talked about supplementary, meaning that it adds up to 180. So if you want to write that there, just as a reminder, but we had it on the relationship before, they add up to 180. To help me remember this one, I think of linear pair and I see the word line. That way I know they form a straight line together. In example 1, we want to solve for x. So I know that this straight line, this linear pair, adds up to 180. I just got to add up the two parts. So I add up the 112 degrees for angle RSU. Then I want to add angle UST, and that will give me my total length of 180 degrees. Angle UST we didn't know, so we had x in the figure. That's why I put x in my equation. Now I want to get x by itself. I subtract over that 112. So I subtract 112 from each side, and my answer comes out to be 68 degrees. So x is going to be 68. The measure of angle UST would be 68 degrees. Example number 2, we want to find the measure of angle KOL. So I have two kind of expressions here. I have 6x plus 9 and 3x as my two expressions. I want to make an equation out of this, and I know for a fact they together form a linear pair. They form a straight line, if you can see here, with that common ray in the middle, the non-common rays making that opposite ray leading to supplementary. So I go ahead and I set up my equation. 6x plus 9, so that angle KOL plus that angle LOM will get me to 180, that straight line, that linear pair that they form together. I go ahead and combine my variables on that one side. So 6x plus 3x gets me 9x. I leave the 9 plus 9, and it still is equal to 180. Now that I have combined everything on one side, I have to move over my number to the other side and then divide by 9. So I subtract 9. 9x equals 171, and I divide by 9 to get my answer. X is equal to 19. Now I do not stop there because that was not what the question was asking. Like example one, it just said solve for x. But here it wanted me to actually solve for the measure of angle KOL. So what I have to do now for the measure of KOL, angle KOL, is I have to plug in that x. So it turns out to be 6 times 19 plus 9. When I go ahead and do that in the calculator, I get my answer. Our last angle relationship for today is vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays, or a pair of non-adjacent angles formed by two intersecting lines. The most important thing is our vertical angles are going to be equal in measure. They're going to be equal in measure. So that means when you're looking at the picture kind of up top, it kind of looks like an X. It's going to be the top of our X and the bottom of our X. Those are going to be equal. And then another pair of vertical angles in that same diagram is the one on the left and the one on the right. So those are what vertical angles really look like in our diagrams here. For example, one, we want to solve for x. So again, I go ahead and find our vertical angles. We got the left and right vertical angles, and the one up top and the one on the bottom. Kind of across the way from each other. They're not touching, they're non adjacent, they're not next to each other. They're kind of across from each other, to be honest. So, my answer, my setup for x here is that x is going to be equal to 72, the angle across the way. Vertical angles are always equal. So x in this case is going to be 72, making that angle across the way from the other 72 the same. Okay, for the next problem, example 2, we have to solve for x if the measure of angle ABC equals 7x minus 8 and the measure of angle DBE equals 62 degrees. So I'm going to go ahead and label those in my diagram. So ABC is going to be this angle right here because I follow the letters. A from B to C, it's going to be the angle in here. Well, what I'm going to write is because I know it as 7x minus 8, I'm going to write it as that. It's not the most precise answer. It's not just a whole number, but it's an expression that I know is ABC right now. For DBE, I'll go ahead and hide that in a different color. So again, ABC was in yellow. DBE I'll make in pink. It's going to be, again, follow the letters. DBE, it's talking about this angle in here. That I'm going to label because I know it as 62 degrees. So again, I'm labeling just the given information first. Then I got to think about their relationship. Well, they are not next to each other. They're across from each other. So I am going to equal them. They're going to be vertical angles that I equal to each other. So I set it up as 7x minus 8 equals 62. I go ahead and add 8 to each side. I go ahead and get 7x equals 70. To get x all by itself, I have to divide by 7 to get my answer as x equals 10. Now I know I can stop there because it just said in the problem to solve for x, no plug-in needed. But that is how we kind of solve our 4 types of angles, our angle relationships we learned today.